Hello guys, how are you all doing? Hope you guys are doing good. Yeah. Guys, welcome to another session of Math. Uh, what we are going to look at today is something very simple. Something simple. It's simple but not that simple. But as you all know, we have been doing it. Yeah, radicals, we have been doing it. And this radical equation here, for SHS, if you are an SHS student, you can also benefit because for this one, mostly it is studied at what? SHS, right? Yeah, SHS. And then if you are a tertiary student, I think in your first year you might look at something like this, or maybe not, but still you can, if you come across it, you can also watch it. Maybe you might have forgotten it, and who knows, one day your brother or sister might come to you requesting of your help about how to deal with this since you have read it all before. So actually, if you're an SHS student or a tertiary student, you can also all enjoy. Okay, so what we are going to look at today is very simple, just a radical equation. And this is not our first video on radical equation. We have done some before, so actually most of you know the steps involved or how to go by when they are giving this equation. So I know most of you will try, and I will not even say it. I'll not even say it because I know most of you will try, and then maybe you will pause the video and then solve it and later come and watch it to the very end to compare their answers, or some will even solve it without even watching the video because they already know how to do it. And if you have not been taught, we have treated it before, so you already know how to deal with it. Okay, all right, now we are going to solve this radical equation here. With radical equation, when you all know what goes into the solution of what radical equation. Okay, so this is not something that for me to be hammering it, because we know something about it already. Okay, what we are going to do here is that square root of 4x plus 1 minus square root of 3x minus 2 is equal to 1. Yeah. You can maintain this equation as it is and then square both sides. You all know that is the first step, right? But if you don't want that one also, you can send either this or this to this side and then square both sides. That is making one of these the subject. I'm talking about how you can go by. Okay, but in this video we will not maintain it as it is and then square both sides. When you maintain it as it is and you square both sides, you are going to get the same answer as we are going to get by not maintaining it as it is. In this video, we are going to make one of these the subject. Either we send this one to this side or we bring this one to this side. We just want to make one of them the subject before we square both sides. That is the approach we are going to use. Now that we know our approach, let's start solving the question. Square root of 4x plus 1 minus square root of 3x minus 2 is equal to 1. Is equal to 1. As I told you already, you can maintain it as it is and then square both sides. You know, when you maintain it as it is and you square both sides, you already know something about Pascal triangles. I mean, the coefficients involved in expanding a bracket which is being raised to a power more than 1. If it is 2, you already know the coefficient. If it is 3, 4, 5, yeah, if it's something like that, we use what the Pascal triangle. So if you don't do it that way and you want to go by what I'm going to do in this video, that is, you have to make one of them the subject. So here we are going to make this one the subject by sending this one to this side. We will make this one the subject. I said make one the subject. You can either make this or this, but here we are making what this the subject by sending this one to this side. All right, so let me write that one for you. Make one the subject of the equation. What this one means is either this or this. That does not mean you should make this one. This one is the subject of the equation. That does not mean you should make this one the subject of the equation. What this one means is that you are to make one of the square roots. I mean, you have to make one of them which is containing the square root what? The subject. So either this one or this. Any question? I hope you not ask any question because we already know how it is. You will be asking questions about when you maintain it and then you square both sides. But you don't worry. In another video, I will use that approach. I will just maintain it as it is and then square both sides. And after that, we will solve it. I will use that approach for you also. So those who wish to use that approach, you don't worry, you can go ahead and use it. If you have any difficulties, just reach out to me in the comment section and I will answer it. But you don't worry, if you're not able to use that approach, I will try and in the next video use that approach to solve the problem. Okay, just for some of you to know how to go by, I mean, when they are to maintain it as it is and then square both sides. All right, good. So we make one of them the subject. What I'm trying to make mean here is that you can either make you have to make those containing the square root. You have to make one of them the subject. So if it is 5, you have to make one of them the subject. If it is 6, you have to make one of them the subject. Here is 2, so we have to make one the subject. But making one the subject, it depends on you. Which of them do you prefer? Do you want to make this one the subject or this one? That one depends on you. So what I can say is just make one of them the subject. Okay, so we are going to make this one the subject by setting this one to this side. Good. So now you can see this one is the subject of this equation. Yeah, this one is the subject of this equation. Now what we are going to do here is that after making one of them the subject, what is the next step? We are going to square both sides. Square both sides. So you're going to square. When you are squaring both sides, please don't square it item by item, or don't square it one by one. I mean, you square this one and then here you square this and then here you square this one alone. No. Square both sides means you have to do it twice. That is, you square the whole of this as 1 and then you square the whole of this 2 as 1. If you don't square the whole of this as 1 and you square it as let's say 1 square plus into bracket square root of 3x minus 2 all to the power 2. If you do it that way, I don't think you're going to get your final answer. You might get an answer, but that answer may or may not satisfy the equation or may not be the solution to the radical equation. So what you have to do is square both sides by considering this whole thing as what? 1, and this whole thing as also what? 1. So you bracket this one, then you square it. You also bracket this one, then you square it. All right. Square both sides. Square both sides. And I've already explained what squaring both sides means. So let's square both sides. All right. Here, when you square both sides, you know, the value of this square root sign is what? Half. Half. And that half means is this one raised to the power of half. And already we are having what? Power 2 here. So it is half times 2. And half times 2 give you what? 1. So these 2 will cancel out with this what? Square root sign. Okay? And here it will give us what? 4x plus 1. Now when you come here, how we are going to expand this one is not the same thing as how we did it to this one. Because this one, the whole of this one is being squared. So the whole of this one is one thing. The whole of this one is one thing. When you come here, the whole of this one is considered as one thing. But in it is being what? Separated by what? An operation sign. Here, this one and this one is being separated by an operation sign. But this one and this one is being this one and this one is all squared. The square root is covering the whole of this and this at once. If the square root was covering, or was covering maybe square root of 4x plus square root of 1, then we will expand it using what? The Pascal triangles. But if you look at this one, it's the whole of this being squared. When it is like this and you are squaring it, you just use the 2 to eliminate the square root symbol, and whatever you get is the answer to it. But if it is of this form, I mean, it is being separated an operation an operation sign, you have to treat it using what? The using the Pascal triangles. I mean, when we have a bracket being raised to power 2, the coefficient involved, you have to use that one to expand it. So here we can't power this and then power this and said we are done. No, the way we are going to expand it is not the same thing as what we are going to expand it. If this one appears to have plus 1 or plus any other number without the square root, or maybe with what? The square root on it, then we will use the Pascal triangle to expand it. But here, as you can see, it is only this. The reason why I'm taking my time to hammer this one is that when you come here, somebody may say, here we are having plus this, but when you come here, also we are having plus this, but this 4x plus 1 here is all under the square root sign. So all those under the square root sign is one thing, and plus or minus another thing will also be considered. But if it is only all those under the square root and you are to square it, you just square it like that, and whatever you get is your answer. Okay, so when we come here, we will square this one and then also square this one using the Pascal triangles. Any question? If you have any question, kindly let me know in the comment section, and I will respond to you immediately. Okay, well, I hope you guys are at least enjoying the video. We haven't gone far, but I hope up to here you want at least have a clear understanding of what we are doing and what I'm saying. Yeah, if that is so, kindly make sure you recommend it to your friend, and also make sure you like, you subscribe, you comment, and share it to all and share it to your colleagues, and invite them to also come and benefit. All right, okay, good. That was just by the way. Now let's move on. So here, as I told you, we will consider this whole thing is another square root. So when we square it once. We will not use any Pascal triangle. Okay, so this one will give us 4x plus 1. Now when we come here, we will use the Pascal triangle, the coefficients involved. Now the coefficients involved are what? 1, 2, and then 1. 1, 2, and then what? 1. So what this coefficient simply means that you will take the first one and then you square it. After that, you will take the second one. You take the first one, you multiply by the second one, which is the first one is this, multiply by this second one, and then you multiply by what? The coefficient of 2. You know it's 1, 2, 1, so it will be 2 times this, and then the last one is what? 1. And then we will take the last one in this bracket and then we will square it again. Okay, so here it's just going to give us 1, and then plus 2 times 1 times this, plus square root of what? Plus square root of 3x minus 2 all squared, and that will give us what? 3x minus 2. Okay, so 4x plus 1 is equal to 1 plus this. Yeah, this is what I was talking about. Actually, this one should have been in the middle, but this is an expression. It is an expression, so anyhow you arrange it, you are good to go. If though it's an equation though, but on the other side is an expression. This is a term, and the whole of this word is an expression. Okay, so here we bring this one in the middle and send this one to the other side. Our next step is going to be the same. Okay, so anyhow you arrange it, you are just good to go, but make sure you just do it to be on the safer side. All right, now here we are going to group like terms, those having square root to go on one side and those without square root to go on what? The other side. Okay, so but before that, here let's simplify what is here first. 3x, 1 plus 3x minus 2, this and this is the same, so minus 2 plus 1 will give us what? That is minus 1, so this side will give us 3x minus what? 1. Okay, just maintain this one and work on this. Please, I put this one in the bracket just to avoid confusion, because here we added some of them. That is, we added this and then this. That is the only whole items here, but we can't add any of this to any of this here. That is why I put this one in the bracket. It means that this one here, when you are either adding or grouping the like terms, it is something on its own. It is something on its own. So when you are adding the like terms, I mean those without the square roots, you just consider those without the square roots without touching it, because you cannot add this to any of these things here. Okay, good. Four x plus 1 is equal to 3x minus 1. So here we're going to group what? Like terms. We're going to group like terms. So we will bring the whole of this to this side. And when you are bringing it here, you all know what it means. When it crosses the equal sign, this one is positive, so it will be minus 3 on this side, and this one is positive, this one is negative. When it crosses this sign, it will be what? Plus 1 on this side, and it will be equal to this. All right. Alright, so 4x minus 3x will give us what? X. 1 plus 1 will give us what? 2. And it's equal to this, right? Good. Now, the equation is now x plus 2 is equal to 2 times square root of 3x minus 2. That is the equation now. So what are we going to do here? Here we can't group any like terms. We can't add or subtract anything. Or the only thing that we can do here is what? Square it again. And why are we squaring it again? That is to get rid of this square root sign. So with radicals, we square both sides twice. The first one to get something like this, and then the second one to get your final answer. So here you're going to square both sides. You consider the whole of this, and then we square, and also consider the whole of this, then we square. Okay? Alright, so let's square both sides. Alright, so here, as you can see, this one is different from what we had on the other side in the previous steps, right? So what we are going to do here is that we are going to treat it using what? The Pascal triangles. This one is similar to the other one, but just that just that this one is having what? 2 being multiplied by this. So we will find out how to expand it, but you don't worry. Okay, so here we will use the Pascal triangle to expand this. That is, it will be this one squared plus 2 times this plus this one squared, and that will give us x squared plus 2x plus what? 4, and it's equal to, now let's come to this side. Now, because we are having another thing attached to the square root of 3x minus 2, how we are going to square it is different from, how we are going to expand it is different from what we saw in our previous session. Here, these two will affect this and also affect this square root sign at the same time. So you will square this one alone and also square this one alone. Whatever you get at the end of the day, you multiply it. Okay, so actually this is how it's going to be. When you square this, you're going to get what? 4. So 4 times, now square root of 3x minus 2 is what? That is, this one will cancel out with this square root sign, and to give us what? 3x minus 2. I hope I'm clear here. I said here you will square the 4. After that, you also square the square root of what? 3x minus 2. Whatever you get, just multiply those answers, and that will be the answer to the 2 times square root of 3x minus 2 all squared. Sure. So let's continue. So as I said, this side it will be what? X squared plus 2x plus what? 4. And then next side it will be what? 4 times 3x minus what? 2. Okay. Any question? I hope there is no question. If it is, let me know in the comment section. Alright, let's expand it, guys. Good. So this is what I was talking about. You see, when you square this, that is the 4 here, and when you square root of 3x minus 2, that is the answer here, and this means we are all multiply. So when you square, this is what we are going to get, and then here we are going to expand it to get the answer to the expansion of this. Okay, good. Here, what some of us normally does is that, I would say some of us, yeah, I'll include myself, right? Yeah, what some of us normally does is that when we reach here, like when they get something like this on either side of the equation, what they do is that they will use this 4 to divide through, or they will divide both sides by what is here. Now, you can do that, but you can only do that. Let me say you can do that, but what I'm trying to say here, what I'm trying to say here is that if you divide through by whatever is here, maybe it can be that you get this one alone. It can also be that you get something together with this. So if this, like this 4 here, when we divide both sides by 4, here to give us what? X. Here to give us 1. But here to give us x squared over 4. And maybe we will add these 2 to blah 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 blah. It will be something else for you. So just divide whatever is here through by first checking if all that is here is divisible by what is here. This and this is divisible by 4, but x squared is not divisible by 4. But if it appears we have something like, let's say 24, let's say 6, let's say 4, let's say 8, yeah, something like that attached to this x squared, and we have also having something like this in it, then we can proceed to divide both sides by this 4, just to reduce this equation to its lowest term. Okay, so you do that when whatever is here is divisible by whatever is here. Okay, but if it is not, if you end up getting some fractions and other stuff, I will entreat you to just finish expanding this side, group like terms, and then factorize to get your final answer at the end of the day, just to avoid difficulties. Okay, I said just to avoid difficulties. I'm not saying if it is not divisible by, if one of them is not divisible by whatever is here and you wish to do it, at the end of the day you won't get your solution. No, what I'm trying to say is that if you cannot if your math is not all that, if your algebra is not good, handling x squared over 4 will be a little bit problem. Okay, like together with in equation like that, it will be problem for some of you guys. So to avoid that, just go by what I'm going to do here or what I said. Okay, so here we're just going to expand it before we group like terms, right? Alright, so when you expand it, this time this will give us 12x, and then this will give us 8. Alright, good. Now let's group like terms. Here is 4x. When we bring this one to this side, we're gonna get 4x minus 12. Here is 8. This one is minus here. When you bring it to this side, it will be plus 8, and that will be equal to 0. So you're gonna get x squared plus 4x minus 12x plus 4x plus 8, and it's equal to 0, and it's equal to 0. Good. So now let's compute this side. 4x minus 12x is what? Minus 8x. Minus 8x. Minus 8x. Now this plus this will give us what? 12. So what we are going to get here is x squared minus 8x plus 12, and it's equal to 0. Okay, so after squaring both sides, this is what we have gotten. So here, what we are going to do here is that you already know what we are going to do. That is what? Factorization. And to factorize this, you already know the approach used in factorizing quadratic expression. Either we use the quadratic formula, the completing square approach, or factorization, or graphical approach. Any of them that we use. Any other that we use, we are just going to get our answers at the end of the day. Okay, good. So here, how are we going to factorize this one? X squared minus 8x plus 12 is equal to 0. Well, what we are going to do here is that already the coefficient of here we are going to factorize. We are using the factorization approach. We will not use the completing square approach. Okay, good. So what we are going to do here is that the coefficient of this x squared is 1. So 1 by 12 will give us what? 12. I did this because we are going to find factors which, when sum up, will give you what is here, but when multiply will give you the product of the coefficient of x squared and the constant here. Okay, so what are the factors? Alright, so we have 1 and 12, and we also have 2 and 6, 4 and 8, 3 and 4, or 4 and 3. But the thing is, after getting the factors, you have to find out which of those factors will give you what this minus 8 here. So when you consider 1 and 12, either if minus 1 time plus 12 will not give you this, so that one won't work. That one won't work. So what will work out here is what? 2 and 6. But this one is negative. But we know that minus 2 and the minus 6, when multiply, will give us positive 12. So minus 2 and minus 6 will replace what? This one. Because minus 2 plus minus 6 will give us what? Minus 8x. Good. Now here you're gonna bracket them. You put bracket on this, and also put bracket on this and that. When you are bracketing them, just forget about the sign in the middle. Yeah, consider the sign in the first one, in the first term and the last term. But what is separating the two terms, just forget it when you are bracketing it. I'm not saying you should forget it at all. No, you consider it when factorizing. But bracketing it, you have to forget it. If you put a bracket on the whole of this, it will be something else. So just bracket this, and also this and this. Good. Here, what is the common factor here? What is the common factor here? Here x is 2, and then here having another x, and we're having 2. There is no 2 here, so 2 is not common in this bracket. The common thing here is what? X. So you just bring x out, and when you bring x out, x squared divided by x will give us what? X. And 2x divided by x will give us what? 2. So it will be x into bracket x minus 2. Okay, so when you come to this side, it will be, what is the common factor here? I think we don't have any common factor here, but we know that 6, though 2 can go here at the same time goes here, 3 can go here at the same time goes here, but it will not reduce it to its lowest term. When you are factorizing, let what remain in the bracket be in the lowest term. Okay, so if you pick 4, if you pick 3, whatever will remain in the bracket is still what? Factorizable. It is not in the lowest term. So just pick out, just make sure that what is in the bracket, what remains in the bracket is what? In its lowest term. So here we have to consider 6. Yeah, 6. 6 is here, and also 6 can go into 12. That means we can bring 6 out, or we can bring all 6 out. So when 6 comes out, 6x divided by 6 will give us what? X. And then plus 12 divided by 6 will give us what? 2. So when we factor out 6, we are going to get x plus 2 to be in what? The bracket. Alright, yeah, here is minus, right? Yeah, it's minus. You will see, though here it was plus, but here you are seeing minus. I didn't see it, but let me tell you why this one as well. Minus, yeah. So here, after factoring out the factor, after taking the common factor out, what you have to do is that the whatever operation sign here, after taking it out, I mean, when we take 6 out, this is our 6 here. This minus sign here is affecting the 6. So when you are using it to find what is supposed to be in the bracket after taking out the common factor, consider whatever sign that is attached to all these 6. Here is minus, so it will be here is minus, so it will be this 6x divided by this minus 6 here. And when we do that, we are going to get what? Minus x, and that is the x here. So when we multiply this by this, is it not the same as this minus 6 here? Don't confuse yourself with the division. You know, this minus sign here is out. Here it is what? Positive. So when we bring this one out and then we are dividing, this sign will affect this one in our final answer, but we will not include it when we are writing it in the bracket. I mean the first item. I hope you are getting me. What I'm trying to say here is that when we bring out 6, like this says here, now we want to find out what is going to be here after taking out 6. So 6x divided by minus 6 will give us what? It will give us minus x. It will give us minus x. But because this x here is already affecting this, we will not bother including it in the bracket, like writing this one as minus x. No. Because already this 6 here, this minus 6 here is affecting it. So there is no need for us to bring another minus sign here. Okay? So when you consider the sign and then you use it to divide, if it is positive, you just write your answer there. But as for this one, it is what? Negative. But after using the common factor to divide, when you are writing what's supposed to be in the bracket, just write the positive one. Just write whatever you get. Ignore the negative sign because it is being affected already by here. Already affected by what is here. All that I'm trying to say is that minus 6x, minus 6 times this x will give us what? Minus 6x. But when we make this one to be minus x, it will be minus 6 times minus x. And that will give us what? Positive x. Positive 6x. Which is not the same thing as what? This. Okay? Remember, this negative sign here is actually affecting this. This one is positive. This one is minus. This one is negative. And then this one is positive. But because we want to find out, we want to factorize this expression, we have to ignore this one, bracket this and this. But in our minds, this one is what? Affecting this. It's affecting this. So because of the bracketing aspect, that is the reason why I told you that when you are bracketing, do not consider this minus sign, or do not consider this minus sign here. If you consider it, it will be bracket of this and then bracket of this. It will be, I don't know, when you look at it, it will be like it is what? Multiplying. Okay? I hope I'm clear here. So here, the answer is supposed to be minus x, but already this minus 6 here is affecting what? This x here. So actually, this whole of this is what? Negative. So just write the positive value there. That is what? The x. Don't write the minus x there because of this minus sign here. Other than that, when you expand it, your answer will be what? Positive. Good. Now here is positive 12 divided by this minus 6. Here the sign got to change because already what is here is different from what is here. This sign is affecting this but not affecting this. This one is affecting this. So when we are using minus 6 to divide plus 12, this will affect whatever that we are going to get, and also has to be included when we are writing it, because the sign that was here, that was affecting this, or that was attached to it, is not the same thing as what was attached to this. I mean, when you look at it from here, here is plus 12, here is minus 6. So when you are dividing it, whatever, if you use this one to divide, whatever minus that is attached to this will affect this and that at the same time. All right, guys. So I hope you guys are. I hope you guys have gotten what I'm saying. I wanted to clear this one because I see some of students making this mistake. That is why I took my time to hammer on it. Okay. So here, positive 12 divided by minus 6 will give us what? Minus 2. Minus 2. Why? Because now when you multiply minus 6 by minus 2, it will give us what? This positive 12 here. Okay, good. Now what we are going to do here is that now this one and this one is the same. So since this one and this one is the same, we will just write one of them and then bracket this minus 6 and then this x. Okay, good. All right, so after factorizing, this is what we have gotten at the end of the day. That is x minus 2 into bracket x minus 6, and all is equal to 0. Now what is the value of what? What is the value of x? We find the value of x by equating each one of these to 0. So first we equate this one to 0, we equate this one to 0, and then we equate this one to also 0 to find the values at the end of the day. Okay, good. So first let's equate this one to 0. Now what is the answer? X minus 2 is equal to 0. So x is equal to 2. So the first value of x from the equation is what? From the equation is what? This 2 here. That is the positive 2. Okay, that's the first value of what? X from the equation. Now let's consider this one. We have to also have to consider equate this one to 0. Or x minus 6 is equal to 0. Yes. Now we will send this one to this side. It is minus. When you cross the equal sign, it will be all positive. So x is equal to positive 6. So guys, the value of x from the equation is what? 2, positive 2, and then positive 6. Okay, but I've told you that anytime you solve any radical equation, check for extraneous solution. Extraneous solution simply means that find out which those values satisfies the equation. When I say satisfies the equation, what I'm trying to say here is that which of them, when plug into the equation, when plug into the radical equation, will make both left and right hand side to be the same. The reason is there are some instances you get 2 or let's say 3 answers, but only one of them will make the equation true. Getting 2 values does not mean those 2 values are the solution to the equation. There are instances both 2 values will make the equation true. When it happens like that, you have nothing to worry about. But what if one of them will not make the equation true? How will you know it? So the best way to find out which of those values that you have gotten is satisfies what the radical equation is to insert them one by one into the radical equation to find out if both left and right hand side will be all the same. That is checking for what? Extraneous solution. So here we are going to check for extraneous solution. That is, you're going to find out, is it 2 or 6 or both satisfy the equation? Which of them satisfies the equation? 2, 6, or both? Yeah, you have to find out that, because you cannot tell the examiner or the marker that 2 and 6 is the solution to the radical equation, where ask only one of them what satisfies the equation. Though it came out of the factorization, but that does not mean it is a solution to the radical equation. So to avoid getting your answer wrong, finding the real value that satisfies the equation, you have to always check anytime you solve radical equation. With those values that you have to always check which of them satisfies what the equation. Okay, so here you're going to check. So checking, this checking here is checking for extraneous solution. First, we are going to put 2 into the radical equation, but please, I will not okay, so we are going to put 2 into this expression here. We are going to put 2 into each of these square roots and find out if at the end of the day whatever we are going to get here will be the same thing as whatever you are going to get here. Okay, so here x is equal to 2, right? Yeah, so whenever you find x, we will put 2 there. Okay, so let's put 2 here. Here will be 4 times 2, and then here will be 3 times 2. Alright, so 4 times 2 is 8. 8 plus 1 is 9. 3 times 2 is 6. 6 minus 2 is 4. So it's root 9 minus root 4 is equal to 1. Let's find out if it is true. Now root 9 will give us 3. Root 9 will give us 3. And root 4 will give us 2. So it will be 3 minus 2 is equal to 1. Now 3 minus 2, is it equal to 1? The answer is Yes. Now 1 is equal to 1. So after plugging into both left and right hand side is now the same. But the question is, will 6 also produce something like this? Well, we have to find out by inserting it into the equation. Okay, so let's put x is equal to 6 into the radical equation and find out if it will satisfy it. Alright, so let's put our 6. I wrote it down just to remind some of you what we are doing. Okay, 4 6 is 48 plus 1 give us 49, so it will be root 49. 3 6 is 18. 18 minus 2 is 16. 16, so it will be root 16. Alright, so root 49 is 7. Root 49 is 7. Root 49 is 7. Now root 16 is 4. Root 16 is 4. Now 7 minus 4, is it equal to 1? Let's finish it. Let's finish it before I say anything. 7 minus 4 give us 3. You see, 3. Is 3 equal to 1? No, 3 is not equal to 1. So you see what I was telling you. If you don't find out which of the values satisfies the equation, and you just say the values from the equation is 2 and then 6 and then just end there, you are going to get your answer wrong. You will be given the marks for various steps, but your final answer is going to be wrong because you did not specify it there. Examiner knows that, or the marker knows that only one of them is the answer to the equation. So if you don't state that one, you are not going to be given a marks for that. So you see, after checking, we have gotten to know that though 6 came out of the factorization or from the radical equation, after solving it, those 6 came out as an answer. but after plugging it into the original expression, we've gotten to know that it does not make the equation what? Balance, though it came out. So you see, not all those that comes out of the quadratic expression is a solution to the radical equation. Okay, and it's all because of the add, subtract, group like terms and those stuff. So it's because of that you have to do for check for extraneous solution. Any questions so far? Now I've taken my time to explain certain things here, and I hope most of you are now clear with all those that were confusing them when solving radical equation. But you still have something that is confusing you, kindly leave it in the comment section and I'll respond to it for you. So guys, 3, since 3 is not equal to 1 or 1 is not equal to 3, 6 is not a solution to the radical equation. So the only solution to the radical equation is what? 2. So therefore x is equal to 2. X is equal to 2. So at the end of the day, the examiner will be expecting you to state that 2 is the solution to the what? Radical equation, because it satisfies it. It satisfies it. Alright guys, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching, and I'll see you in another video.